So, first of all, good day, sir. I am Agustin Gasanikmar B. Boyles, first year BSMT, section Gacrox. So, this is my lecture outcome assessment. So, task number 1, explain the illustration of the operating principle of how Icosender measure the depth below transducer. So, this is my illustration on how I understand this topic. So, first of all, what is the principle of ecosonder operation? So, an ecosonder is an instrument system for indirectly determining ocean floor depth. So, ecosonding is based on the principle that water is an excellent medium for the transmission of sound waves and that a sound pulse will bounce off a repeating layer returning to its source as an echo. So, water, this is the water as I draw. As it matransmit siya by way of sound waves. So, transmission of sound waves and that the pulse of will bounce off a reflecting layer returning to its source and as an echo. Ano siya dire? So, an echo sounder works state or it operates to know the depth of the water under keel by a depth finder, so also known as echo sounder. So, this is a device on ships to determine the depth of water by measuring the time it takes a sound or sonic pulse produced just below the water surface to return or echo from the bottom of the body water. So, matransmit siya by way of kuan. Na siya sound wave nga makuha mo na siya mo transmit siya sa echo sounder. So, mo na pagsabot na ko, sir. Then, transducer. So, the function of transducer in echo sounder. So, the transducer mo ni siya mo convert sa pulse into sound like a loudspeaker which transmit towards the seabed. So, mo na siya makuha sa kuan og kanang hapit na kuan sa yuta sa ilawom sa dagat. So, when it reaches the seabed, this pulse is reflected back to the transducer, which now acts like a microphone and converts it back into an electrical current. So, that's my explanation, sir, on how I understand this illustration that I make in task number 1. So, task number 2, explain through illustration formula of how the depth below transducer is being calculated. So, this is my illustration as I understand the topic. So, as we get this distance, so the sound pulses are sent out regularly. So, as the ship moves along the surface, then which produces a line showing the depth of the ocean beneath the ship. So, this continuous depth data is used to create bathymetry maps of the survey area. So, and how we get the distance is D equals V times time over 2. So, a short pulse sound energy transmitted vertically down. So, mo na siya ang echo sounder. Short pulse sound energy ma-transmit mo na siya na time taken for it echo back is used to determine the depth. So, ma-determine ko no ang kalawmon through short pulse sound. So, time taken for it to echo back is used to determining the depth. So muna siya time, so how to get the time taken, t equals 2 times d over b. So that's all. That's my illustration on explanation on how I illustrate the task number 2. So task number 3, explain the 7 identified errors of the ecosounder. So this is how I explain the errors, why they occur in the ecosounder. So errors of the ecosounder explain why this happens. So as the velocity of propagation in water, the velocity of acoustic wave changes if temperature, salinity, or pressure changes, and since velocity is not correct, the depth record will be inaccurate, and also bubbles and aeration causes errors. Multiple echoes in shallow waters also causes errors, and lastly Pythagoras errors and slanted distance. So these are the common errors of occur when you are in the ship and as you use the ecosounder, as I understand. So these common errors when occurs, the depth record will be inaccurate. So di dayon makuha ang saktong record if naka sa shallow waters or slanted nga distance sa ilawom. So that's all for my task number 3. Good day, sir.